What's going on, my friends? It's Chris over at VerrilloTrading, and I am sitting in the dark, even though it doesn't look like it. In this video, I'm going to show you a Telegram bot that I made to trade on the cryptocurrency exchange named Kucoin. And this is an interesting program that I've built here, and I only use it personally right now. So I'm going to show you how it's built. I'm going to show you some of the code later on in the video. I'll show you how it works first. And that's right. So let's get on with it. If you want to learn more about how to build Telegram bots and certain ways of implementing them, certain little nuggets of knowledge you might need if you want to build your own Telegram bot, and maybe some info about HTTP and WebSocket libraries and coding, well, you came to the right video. I'm going to try and keep it simple so that the average viewer can also follow along with the video and not be totally confused. So the basics of what is going on here is I've created a program and it operates in the form of a Telegram bot. And this Telegram bot, you can interact with it as a user and it can place trades for you in your KuCoin cryptocurrency account. So let's show some of the documentation first. So this is what's being used here in this video. Of course, I'm using the Telegram Bot API, which is a HTTP interface that is used to communicate with bots on Telegram. I'm using the KuCoin API, which is also a HTTP interface, but there's also some WebSocket implementations that you can use as well. And I'm using one of those here in this bot that I'm going to show you. And to perform the HTTP and WebSocket stuff, I'm using Boost Beast here in C++, which is a library developed by Vinny Falco. Okay, and it's built on top of Boost Asio, which is the lower level stuff. So let's get on with it right now. I'm going to show you how the bot works. So this is the bot. It's called VT KuCoin Lender. I'm on Telegram desktop here, but this will obviously also work on mobile. And the point of this bot is to submit lend orders, to lend your cryptocurrency on the KuCoin exchange automatically. Now, some of you might say, well, KuCoin already has an auto lend feature. Well, the reason why I made the bot is because I found that their auto lend feature wasn't that good. And I decided I wanted to make it better, more flexible, with a better user interface. Okay, so this is the bot right here, and it's only going to work if I send a message to it. If any other user other than my authorized username sends a message to it, it's going to get a message right back to them saying you're not authorized to use this bot. Simple as that. You know, if you try and message it, you're going to get that message. So don't message it. And then I'll talk to the bot now. Here it is. So I'm talking to the bot. That's the start message. Now let's go to the main menu. Okay, so I'll do options. Okay, so we have this main menu here, and some of this information is obviously, you know, this is a real account, so you're seeing some real money right there. So these are the options that it gives you right here. I can subscribe to the live order book. I'll show you that in a minute. You can see here that these are available funds in the account. I can subscribe to account updates, which I will show you that. This is using a asynchronous WebSocket operation, which I'll show you how that works in the code later. And you can submit lend orders and you can cancel existing orders using this bot. So let's go ahead and show how that works. So if I go to cancel lend orders, because I already have some orders there, you can see that I have one order actually that's already been submitted, and I can cancel it, or I can cancel all orders if I wanted to. If I click here, it's going to cancel the order. So I'll go back to the main menu for now. And let's say I wanted to submit an order. So I'll do lend USDT 7-day. And that's the only time frame that I do lending on this exchange, because it just makes sense to do it in the short term, because you're getting repaid fast for your loan typically. So I'm going to type in the amount that I want to lend. It must be a round number and it must not contain special characters. So if I type in like a letter, or if I go like 1.5 or something like that, it's going to say that is not a valid amount. You must type in a full integer, because that's how it works. And it also works that way on KuCoin. So I'll type in 100. Okay. So now it'll say, okay, creating a new lend order to lend $100. Select the price from the order book and enter it below. Okay, so here's the order book. We just got a live quote of the order book here. The best offer is currently at this rate, which is, you know, not a great rate in my opinion, but it doesn't matter. So what I'll do is I'll click here on this rate right here, and it copies it to the clipboard. This is called mono text formatting, using the markdown method. I don't remember all the technical terms, but basically it's a type of text formatting that allows you to copy it to the clipboard. So now it's copied to the clipboard. I can paste it and I can send that as a message to the bot. And now it asks me, do I want to auto lend that 100 USDT at this price again when it's repaid? That's a feature I'm still working on here. But let's say we don't want to do that right now. Let's say we submit the lend order just like that. Okay. Order has been successfully placed. Okay, now let's go over to cancel lend orders, and we can see that we have this new order that's been placed right there. Okay, And probably I should log into my Kucoin account to also show you that the orders are there to prove it. Okay, so now I'm in my Kucoin account here, and you can see these 2 orders are right here. Okay, and I'm going to go back to the Telegram bot now. And what I'm going to do is go over to cancel lend orders, and I'm simply going to cancel these orders, cancel all orders. Okay, all orders successfully canceled. Now if I go back here and refresh the page, we will indeed see that the orders are gone. There are no orders right there. Okay, so I assure you that it's all working fine. I've done a lot of work to make sure everything's working good. So back to the main menu now. Let's talk about the order book. So I can subscribe to the USDT lending order book right here. If I click there, I can see the live quote of the order book. And I can get real-time updates. So like a real-time updating order book here, it's going to update. In this case, I programmed it to do it 1 time per second, but you can obviously do it faster. There are limits because I'm using HTTP requests for this. So it's constantly making the request. There's limits to how many requests you can do to KuCoin, although it's quite a high limit. So you can see here that the order book is updating. We can see the live values are changing right there. All right. Now, if we go back to the main menu here, we can do that, or we can stop the updates, or we can submit a lend order here from this menu as well. So let's go back to the main menu for now. Let's talk about account updates. So the account updates feature is very interesting because what happens when we click on Start Account Updates is it actually launches an asynchronous WebSocket operation that subscribes to one of the KuCoin WebSocket feeds, which provides an update in a JSON format every single time there's an update made to the trade account. So it launches that operation, and the reason why it needs to be asynchronous, I'll show you guys in a minute why, but it has to do with keeping the connection open. Okay, so that's pretty much all this bot does. I mean, the point of this bot really is so that you can go in, submit your lend orders, and auto lend them. So for example, let's say I want it to lend 2,000 bucks. I'll submit another lend order here, and I'll just put it at this price. Okay. Now I'll submit it with auto lend, and that's good. Now if we go to auto lend settings, or actually let's start account updates right here. Let's start the account updates. We can see our active order right there. We don't have any unsettled trades, meaning we're not in any trades. You can see our available USDT is lower than it was earlier. And we have 2,500 in open orders. Okay, so let's go over to the auto lend settings. All right, and you can see the auto lend amount currently has been set to 2,000. Now we can change that amount if we want, and we can also change the auto lend price. Now I'm not finished developing this feature of it yet because there's some thought that has to go into it a little bit, but definitely I think it's going to be an interesting feature. All right, so we'll go over to the code now, and I'll show you guys certain things. So the main program itself is a HTTP server, which is based on an example by Boost Beast. If you go to this page right here, the documentation for Boost Beast, you'll find the basic examples. So that's being handled all here at the bottom. So this is the function list here on the right side. So if we go over to the functions here at the bottom, these are the ones that are handling the incoming requests. The main function, I'm not going to show it to you because it has some links that I haven't put into environment variables yet, and some of them are private. But basically what the main function has there is it's a HTTP server. So it waits for connections. It waits for HTTP connections to the server. That's all. So the do session loop here handles the HTTP request, and it sets certain parameters regarding that. And more importantly, what it does is it triggers this function called handle request. And the handle request function, which is right above here, this is where we are handling the specific endpoints on the server. So I'm handling multiple different endpoints here. You can see this is one of them. That's for one bot. This is for another. This is for another, and the Kucoin bot is over here. What this says is if we get a post request to the server and the endpoint is at this endpoint, Kucoin lender, then we're going to respond with this. And the reason why this is implemented this way is because I'm using the webhooks method, meaning that as soon as the bot receives a message from anybody or receives any interaction, Telegram sends a HTTP post request to my server. That's how the webhook works. So this is what happens when Telegram sends us information about our bot. It goes here, and it's going to then trigger this right here, this function, which is Kucoin Lender Bot, and it's launching it in a separate thread. And it needs to be launched in a separate thread. At least I'm pretty sure it does, because there's some operations that take place in this function that sometimes they continue to operate. And at least I noticed it was problematic if I was doing it synchronously without launching it in a separate thread. With these other bots, like for example, I have a calculator bot, this one right here, there's always a response to everything that happens, and there's nothing that continues to operate in the background. So that's why it's fine to launch it synchronously. So what we're doing with these functions here is we're passing in the JSON body that Telegram is sending us. So you can see their input. That's what's happening. Every time Telegram sends us the JSON object to the server at this specific endpoint, we parse it right here into this variable called input, and then we're passing in the input to that function. So in this case, Kucoin Lender Bot. Let's go over to that function and see what it looks like. So this is the function that's handling every single action of this bot, everything that this bot is about. Okay, so we'll go over the basics first. This is some stuff that you're probably interested in if you do any kind of Telegram bot development. The first thing is here, input.find my chat member. If this gets sent to the bot, it means that somebody blocked your bot. It means that somebody said, I don't want to talk with your bot anymore. And if you're not handling this, it's probably going to bomb out your server. So you have to make sure you're handling this. Okay, then the other thing is we're just getting the chat ID, but we're only getting the chat ID if the input was actually a message. And then the next things we're handling here are callback queries. So I'll talk to you guys a bit about what callback queries are. So a callback query is the term that Telegram uses for when a user taps on one of these buttons. So when I tap on a button like that, it's not a message that's being sent, it's a callback query. So basically I'm handling different callback queries. I'm handling a whole bunch of different ones here. And you can see that's implemented in the form of an else if, but maybe that could be, done with a switch. But honestly, I haven't found any issues with that right now, so I'm just leaving it like that. I'm sort of a paint spewer when it comes to coding. Like I'm coding it, I'm just going with it. I'm coding it. I'm doing it as efficiently as possible. And I already know that, C++ is a very fast and efficient language, and I'm trying to minimize the calls into persistent memory as much as possible. But at the same time, I'm building it first, and I'm worrying about optimizations later. And that's how I can, code stuff relatively fast. So we have our callback queries here. And the first thing, of course, when I send the options message right here, well, this is the thing that handles the username. So basically what this is handling here is the various text fields that the user sends to the bot. So when they send the start message, it gives them this, right? Which is nothing special. It's just a simple start message. So this is the request we're making a Telegram to call the Telegram bot API. So in this case, it's a function on its own. It's called HTTPS post JSON. It has 4 inputs. Basically, it sends a HTTP request to Telegram with this JSON object here that I've constructed, and it's telling it that my bot's going to send a message to that user that talked to it with this message right here. That's all. If they send the options text like this, then they get a main menu. Okay, so this is a little bit more interesting because now we have to send them an inline keyboard. Inline keywords are pretty cool in Telegram. That's what is being used here to provide this menu interaction right here. That's called an inline keyboard. Okay. So what we have first is we need to start making some requests to KuCoin. And I guess this is where it can get a little complicated. So there's another function right here, another HTTP request function that, of course, it's a boost beast function. And it's called HTTPS KuCoin get. And it's also configured with all of the KuCoin API key, API secret, and all the parameters you need to provide in a KuCoin request, which is more of the low-level implementation details. I'm not going to cover all that in this video. But in this function, that's all being taken care of here. And we're sending a request to this endpoint right here to get information about the trading account, the KuCoin trading account. So then if the get result is okay, meaning it was a successful request, we go ahead and we parse the JSON right here into this variable called response body. And then what we're doing is we're declaring some string variables here. And then we're iterating through the JSON at the key data, and we're getting the information for our trading account. And you can see in this case, as I have an if statement in here that says if the item type, which specifies the type of account, because in Kucoin there's like 6 or 7 different trading accounts. We only want the one for the main account. So if type is equal to main, get the variables, and as soon as we get them, break the for loop and get out of there. So this could be used if you need to iterate through, all the different accounts and all that. That's it. So once we get the values into our variables, I then construct a boost format function, which I love boost format. It's a great way to format variables. It's actually pretty easy to use compared to things like printf or format with printf. I don't know what people use these days, but I like boost format because this is sort of how you can do it, where you type in your text and then you do %1, %2, %3. You don't even have to put in what type the variable is. You could if you want, but it'll do it for you basically. In this case, they're all strings anyways. So that's our boost format object, and then we're putting that into a string, which has been declared up here, tg text, and we're using the str function to change that boost format object into a string. So now we have our string here that we've constructed. We're constructing our text that we're going to provide the user when we send them the message. Then what we have here is we start constructing the inline keyboard. And the way this is done is with JSON objects. So every row of the inline keyboard has its own JSON object. So you can see here, this is the first one, subscribe to the USDT lending order book. And then the callback data. So the callback data, this is important because this is what's going to appear in the callback query when the user clicks on this specific button right here. So you need to make sure you're handling each callback query that you configure here for each button. So this one is called USDT_book. So like I said, each row has its own object. In this case, I'm checking the state of a global variable, and depending on the state of that, I'm either going to show them account update start, or if they've already enabled account updates, then I'm going to show them account update stop for this particular row. Then for row 4, here's an example of having 2 buttons in the same row. Okay, lend USDT. We have post lend order and cancel lend order, and then there's just a URL there in the last row. And then we construct our inline keyboard markup object, which is an array which contains all the rows, row 1 all the way to row 5. Next, what I'm doing is I'm appending a quick piece of text here to that Telegram text object. And once I'm ready with that, I construct the final JSON object that takes care of the Telegram request. This is the JSON object that Telegram is going to receive that's going to tell the bot to do something. So we have the chat ID that we're sending it to. We have the text that we're sending. We have the reply markup, which in this case contains an inline keyboard markup. And then we have the parse mode, which is Markdown. They have a more advanced one called Markdown V2, but I never got it to work yet. But Markdown is fine because you can do bold text and mono text, and that's perfectly fine. Then we're sending the request to Telegram here with our bot token there. And we're calling the send message method. And we are attaching the JSON object here that we just created called reply keyboard, but really this should be called message. And then if the status of the request is okay, we just post a JSON to the server just to make sure everything was okay. And if not, error with the response. Okay, so that handles the main menu right there. Next, what we can do is go up and look at some of the callback queries. Okay, so let's go ahead and look at account updates because this is going to trigger an asynchronous operation, which is a little bit interesting. So I'll go over to the callback queries, and when we receive the callback query with the name account_update_start, this is what happens. So the first thing is I set the account updates global variable to 1, and I guess I should make a note on global variables. I'm using them quite frequently in this program, but in the future I want to upgrade and use something like a database, like an SQLite database that is like a client-side database that can handle remembering the state of all of these global things. And I think that that might be more efficient. I'm not so sure, but if any of you guys use SQLite and you're a C++ developer, you can reach out to me and let me know how you find that. And if you think it's more efficient than using global variables. I personally think it would be, but again, I'm not an expert developer. I'm just learning. So here we go. The first thing we do here when we receive a callback query from Telegram is we have to answer the callback query. This is technically what you are supposed to do. If you do not answer the callback query that Telegram sends you, basically you're going to get an endless loading screen at the top because you're not answering the callback query. So you should answer the callback query. I don't think you're obliged to answer it, but I think it's good practice to answer it. Now in this case, I wanted to see if it would improve the performance if I answered the callback query in a separate thread. I think it does because it might save a couple milliseconds. Instead of having to wait for the response object to return, it simply detaches it. Anyways, I'm not so sure if this is improving performance. Okay, so let's go on. The next thing we do here when we are ready to subscribe to account updates is there's a few requests that are being made to Kucoin to provide this information. So when I click on Start Account Updates, it's getting all this information right here. It's getting the available cash and the amount that's in open orders. It's getting if there's any active trades that are currently active and unsettled, like open trades that you have that are accumulating interest. And it's getting any open orders and putting them all here. So before we actually start the asynchronous operation to subscribe to the account updates, we're performing some requests to get this data first. So these are the requests that we're making to Kucoin. So we're making a request to the account data here, and we are initializing our string to this. Next, we make a request to the active land order list, which actually is the unsettled trades list. Then it's checking if there are any. If there are none, it simply says there's no active unsettled trades, and it appends that to the string. And if there are active land orders, then it's going to perform this right here to get that information. And it's a little bit complex. I'm not going to go through all this code with you guys. But basically what we're doing is we're extracting some variables from the JSON. We're assigning them to these variables with the correct type. We are calling a time conversion function here to convert the time in milliseconds that Kucoin provides us to a readable human time format. And then we're formatting all that to an output string stream. And the reason why I had to do that is because I wasn't sure of any other way to use this std put time function in the year, month, day, hour, minute, second format. So I did it that way, and then get the string out of that, and then create a boost format object and append that to our Telegram string. And then the last request we're making before we start the asynchronous operation is to get the active orders if we have any open orders that have been unfilled. So again, it's a GET request to this specific endpoint right here for Kucoin. And then the first thing we're doing is we're parsing the JSON and we're checking the number of active orders. So the items field in the data key is an array. And if the size of that array is 0, which is here, then it means there's no active orders to cancel. So we simply append this to our string. If the size of that array is not 0, it means that there are orders, active orders. So what we do is we tell the user how many active orders there are by using the boost format function to format this variable into the text string. And then we're appending that to our string. The next thing we're doing is we're getting the active order information right here from the JSON object, and we're assigning it to some variables here locally. And we are converting the daily interest rate to a yearly rate so the user can read that. And then we're just doing another boost format here to create a nice readable string for the user. And then we're appending that to our string. Now we're finally done appending things to our string. So what we do is we construct our Telegram inline keyboard yet again, and it's pretty much the same keyboard I showed you before. And then we construct the keyboard object here. We construct the message object. And this time we're submitting the edit message text method to Telegram instead of send message. And that's what allows us to always get the same message edited over and over again. So if I click on any of these buttons, you can notice that it always edits the same message rather than sending a new message every time. So I'm using edit message text for that. Now we can finally go on and look at how the asynchronous operation is taking place here. And this is, I guess, where it gets a little complex. So get your coffees ready. So before making an authenticated connection to their WebSocket server, you have to submit this HTTP post request first to this endpoint right here. And I guess this is the authorization endpoint, and it's telling Kucoin that you're about to initialize a WebSocket connection. When you make a request to this endpoint, it provides you certain data that you need in order to establish an authenticated WebSocket connection. So here's our first request to that endpoint. It's a post request. We parse the JSON response, and then we get some data from that response. We get this variable here, the WebSocket token. We get the WebSocket host. And this is just for debugging purposes. I can comment that out. Now, the purpose of this string parsing line right here is written right here. What you get from the JSON is this, but the host that's necessary to make the WebSocket connection needs to be this for our beast WebSocket connection. It needs to be that. So that's what the string line is doing here. It's removing the 6 first characters and cutting the last character. And then we start with the WebSocket upgrade here. So we have our lower level stuff for the WebSocket, our IO context, our SSL context, and loading in the root certificate used for verification. And then we launch the WebSocket operation here using this right here. This is launching an asynchronous WebSocket operation, and we're going to talk about what that means here in a second. So I don't know about all the lower level implementations about this. I still have to watch Vinny Falco's video over again. I probably already watched it 3 times. I need to watch it another 10 before I fully understand all the details about how this works. But I do have a decent understanding of it. So it launches the operation in this object right here, the session object, which we will go to in a second here. And we're passing in some of these variables. We're passing in the host, the port, the WebSocket token, and a couple of the variables regarding the Telegram callback chat ID and the inline keyboard message ID that we're going to be editing. The reason why I'm passing in the inline keyboard message ID is because when Kucoin provides us an update about a lend order being repaid, this message is going to be deleted and it's going to send us a new message to ensure that the user is notified. So it needs to know the message ID of this particular message. That's why I'm passing that into the asynchronous operation. So once that's been launched, this current thread gets blocked and it's now used for the completion handlers for our asynchronous operation. So now the thread is blocked right here as it's calling run on our IO context. And in the case that we get disconnected, this is what happens. The first thing is we have a sleep for 2 seconds. The reason why I put this here is because this whole asynchronous operation is wrapped in an endless for loop, which is what I call a redundancy loop that will ensure that if we do get disconnected by Kucoin or by an internet disconnection or something, that we reconnect in 2 seconds, that we submit a new request to this endpoint, get the new WebSocket token, ID, whatever, and then go ahead and launch the asynchronous operation another time. So this is our redundancy loop right here. And the way we get out of this here is when the user calls stop account updates, it's going to change the state of a global variable called account updates right here. And you can see that the first thing it's doing in the endless for loop is it's checking if account updates are equal to 1. If they are still 1, means that we need to reconnect. If the user has set it to 0, meaning they said that they wanted to disconnect from the account updates, then we go all the way to the bottom here and we simply return and we bomb out. And now no more WebSocket. Okay, so let's go ahead and look at the asynchronous operation here that's taken place here in this session object. So I'll go over to that particular function, and here's where it starts. So again, this is derived from a beast example. It's derived from their asynchronous WebSocket client example, and I just simply adapted it to my own use case here. I can't really explain to you all the lower level implementation about this, but I do know that these are just some of the general variables here. So we have our run function here, which we're passing in our callback chat ID and our inline keyboard message ID from Telegram. And we're initializing those 2 variables here that our session object is aware of. So here's our list of asynchronous operations that take place. We have run, on resolve, on connect, on SSL handshake, on handshake, all the way down to on close. All these are different functions that they trigger one another in the asynchronous operation. In simple terms, because I know I'm going to lose a lot of people here, Each one of these functions is set to trigger the next. So the onResolve function calls async connect, and once it is done connecting, it triggers the onConnect function. And then the onConnect triggers SSL handshake, and then SSL handshake triggers onHandshake. So once we're on the handshake function, it means that we have successfully connected, and we now want to get the welcome message from Kucoin. So when we subscribe to a Kucoin WebSocket, it sends you a welcome message, and you have to read that message into the buffer. So we're calling Async Read, and when the completion handler returns that read, it then goes ahead and triggers onSubscribe. The first thing we're doing here in onSubscribe is we are outputting the welcome message to the console, just to show it there. And now that we know that we've received our welcome message, we're going to go ahead and subscribe to one of the Kucoin WebSocket feeds. And we're doing that like this. We have the object here, it's a JSON. We're converting it to a string, and then we're passing that string into async write. So we're writing this message to the Kucoin WebSocket connection and informing it that we want to subscribe to this particular endpoint, which is account balance. So it's going to give us information about our account balance, updates, any updates regarding our account balances. When we get lend orders repaid, when lend orders are submitted, when any trades go through, all of that. Okay. So once that write goes through, it calls on read subscribe. Now this is where it gets a little technical. Okay, so the first thing we're doing after we send the write message to subscribe to that WebSocket feed is I'm actually calling a synchronous read here, just to get the message that it's been acknowledged that we are connected to that feed. And this is a synchronous read, meaning it's going to block until we get something printed by the server. And because we just subscribed, we should get it immediately. That's what's supposed to happen. So this is not the initial welcome message. It's actually the acknowledgement message. The initial welcome message was printed up here. This is actually the acknowledge message, which means it's acknowledging that we've connected to that particular WebSocket feed. The next thing is, before calling any more reads, I'm clearing the buffer to make sure we have a fresh buffer to read the proper JSON objects. And now we're ready to read the account messages from the socket. So this is where the important stuff is. So the first thing is we're calling async read. And when the Kucoin feed gives us an account update, it's going to trigger this function right here on read. Now the reason why I needed to do this right here, you see this? We have timer.async wait. This is very important. It's because obviously you're not receiving account updates every 5 seconds. Sometimes it could take a very long time to receive an account update. You don't know when the account updates are going to happen. And what happens with the Kucoin WebSocket connection is that if you do not send a ping to their WebSocket server every about 10-15 seconds, they disconnect the client. So what I have is the async read here that's going to wait for Kucoin to send us an account update. But at the same time, we've configured a timer here. In the case that there are no account updates, we do not want to be disconnected from their server. So we have a 10-second timer in this case, and we're calling async wait on that timer. And then when that timer goes through, it triggers this function called onTimer. And what the onTimer function does is this. The first thing we do is we just make sure the timer expired. If the WebSocket connection is still open, we go ahead and we call async write and we send the ping to the server. If the WebSocket has been closed, it means there's been a problem, so just disconnect, just return, just bomb out, doesn't matter. Once we send the ping, we again call timer.async wait, meaning we are restarting the timer again. And then the last thing we're doing here in the onTimer function is, in the case that the user requested to disconnect from the account updates, so in this case, if account updates is equal to false, we are going to call async close, which is going to basically close the socket, close the WebSocket connection. I know it's complicated to understand the asynchronous operations. Even I don't understand it totally. But basically, there's this thing called a completion handler. So what the completion handler is doing is it's basically sitting there and waiting for our asynchronous reads, in this case, our asynchronous timer to finish. And when they finish, it calls the function that we told it to call. And meanwhile, we can continue doing any other operations in the background, and no functions are blocking. So basically the point of calling async read and async wait is because we need the timer to be operating constantly while we have that read working in the background, waiting for those account updates. So if an account update is never returned, this read here, nothing's going to happen with it. We're just going to continue operating and the WebSocket's going to get disconnected. That's why we need this timer here, which operates in the background, and it's calling async wait. So when that 10 seconds passes, our completion handler is going to call this function on timer, while again that read function in the background, this one here, is still waiting for the server to provide us a response. So this is operating in the background asynchronously. And our on timer function is called after 10 seconds passes. All it does is it makes sure our connection is open, sends the ping to the server, and then it calls async wait on our timer again for another 10 seconds. Meanwhile, that read is still happening in the background here. So now let's go on and look at the read function. So when we finally get an account update, this is what's happening. So the first thing we're doing is we're parsing the response. We're converting it into a string for debugging. And I'm not sure that's necessary anymore. We're checking the size of the buffer. If it's not equal to 0, and it's not a pong message, because when we send the ping, it returns a pong message back to us. So if it's not a pong, we continue and we perform this. If it is a pong, nothing happens. We just clear it. So I had this right here, which handled the pong, but it's only for debug purposes. So it's commented out right now. Once our read finishes, again, all of it takes place in this if statement right here, which makes sure it's not empty and it's not a pong. All of it happens here. So once it's done reading and performing all the function that we needed to do, it goes ahead and clears the buffer, and then it calls async read again. It calls another read. We always have an ongoing read in the background because we want to be notified anytime there's a new account update. We want to read it and process it. So when we receive the read, it's being processed here. So the first thing we're doing, of course, is we are parsing the response into a JSON, because I'm using this Nlaman JSON library. I'm sure you've seen that just by looking at my code. So I'm parsing the JSON. I'm getting the variables. I'm changing the available cache balance in the global variable. And then what we have is 3 main things that we're looking out for. And the most important one is this one, lend order repaid. So now, once we have the JSON response that has been sent to us by Kucoin when we received an account update, we're now ready to parse that response and check what it contains to determine what kind of update it was. So in order to get these if statements here, I had to study the JSON object itself to determine a reasonable statement that I could construct to make sure that it is indeed the account update that I am going to be handling. So in this case, if we get a lend order repaid, this is what I'm checking for. So the first thing is, if the relation context key from the data key of the JSON is not empty. So if it's not empty, meaning there is something in the relation context key here. If it is empty, then it was surely not a lend order repaid, because when we get a lend order repaid, this field always has something in there. The next thing we're checking is in the relation context field, if we find loan repay detail number, this key right here. If we find this in the relation context field, then we are pretty sure that this is a lend order being repaid. The first thing we do is we call delete message, which is a Telegram method here. And we are going to be deleting the message of the Inline keyboard. The reason why I have to delete it is because we're going to be providing them with a new message to ensure that the user is notified. A couple of variables for getting data out of the JSON. The time that it was repaid right here, and we're calling a time formatting function right here, converting the millisecond time into a formatted time. That's being taken care of in this function right here, format KC millisecond time. I'm not going to show that, but basically it's formatting the time. And then what we're doing is we're calling some HTTP requests to Kucoin, getting the unsettled land order list, and then we're getting the active orders again. And then, which I haven't handled all of yet, is if the user enabled auto lending, this is where it's going to be handled for the program to resubmit a new order upon the lend order being repaid. In this case, there's nothing there yet. Then we construct our inline keyboard and send the message to Telegram, to the user. And at the same time, since we deleted the prior inline keyboard and we sent them a new message with our inline keyboard with the update and all that, we have to increment our inline keyboard message ID variables here to inform the rest of the program of the new message ID for the inline keyboard. If you kept the inline message ID the same, then if you go and start calling and clicking on other buttons on the new message, it's not going to edit them because the program is not aware of the message ID of the new message that has just been sent to the user to notify them of the repaid order. Okay guys, I'm going to leave it there for now. I'm going to go ahead and submit another land order here just to end off the video. I'll submit it at that price, copy to the clipboard. I'll just submit a plain old land order, and the land order has been placed. Okay, let's start account updates, and we can see that we currently have 2 active land orders right there. Let's cancel them, and we'll cancel all orders. And there's no active land orders now. All right, guys, thank you for watching. Take care.